So the lectures, once they're recorded, I'll convert them. That takes some time, but I'll post them to YouTube, and this link will stay here so you can access if you miss, especially valuable for that. But they'll be here. So my office hours are listed here. It's in B1313. So the main math area. If you go down the hall and make a right, that's where 1313 is, and these are the times that I'll be in there. So those are totally open to y'all. You don't have to make an appointment or schedule anything. I'll be in there. You just show up if you have questions, issues with things, comments, concerns, whatever. I'll be there. I'm also in the math center from 3:30 to 4:30 on Tuesdays, and that's more of a kind of an open space for all students. So it's, if you need like one-on-one, then office hours would be best. But I'm also available there as well. There's just maybe other students where I have to like bounce back and forth. So just keep that in mind. If these office hours don't work, then we'll probably communicate mostly through email. Sometimes I do have a little bit of flexibility in my schedule. So if those office hours don't work for you, just let me know and propose some certain times that do work for you, and I'll see if I can make it work. I can't guarantee anything, but everybody's schedule's so different with what classes they take. I do want to make sure that I'm available to those of you that want to utilize that. So just let me know. And maybe it goes without saying that communication is like really important overall. Especially if you have to miss an exam, any kind of thing like that, just communicate with me, and 90% of the time we can work stuff out, whether it's specified in the syllabus or not. Sometimes there's ways around things. The course materials that you do need are basically you just need a access code. So you don't actually need the physical textbook. If some of you have taken classes here before and used MyMathLab, then that's what we're using in this class as well. So in order to access that, you do need to buy an access code. You don't actually need the physical textbook because the textbook is online as well. So I'm not sure if this 280 is accurate, because I know last semester was like $415, but this is the price that a manager in the bookstore gave me. I'll have to double check, or maybe you can check before I get a chance. But to me, that seems low. I don't know why they would decrease their textbooks. I don't know that that's ever happened in the history of textbooks. So last semester was like $415, but it is good for Calc 3 if you have to go on to Calc 3 as well. So you can buy that with the bundle. You can buy the code through the bookstore, which is $140, or you can buy the code through the direct link in MyMathLab, and that's on our main D2L page. So once you're in this course, the way you access MyMathLab is here. So if you don't have access, it'll ask if you want to purchase now or to access temporarily or something like that. So that's where you would buy it as far as like the cheapest option goes. So that's about $120 through this link here. And make sure you're getting it one of those ways. So either through the bookstore or directly through that link. Any other method, Amazon, etc., won't work. If you've taken the class before, you should have no issues logging in. So if there are any issues, then just let me know. I really don't have much control over it, but the sooner we can work those kinks out, the better. There's always issues. Okay. But regardless, you do need an access code, one way or the other. I'm just curious, who's used MyMathLab before? Okay, so most of y'all. All right, I will go through a little bit of kind of the interface and where things are. So with that being said, you do need internet access. The computer the computers down this hall and the computer commons in the math center, I know for sure like they're all set up to run MyMathLab. So, you know, if you don't have internet access at home, you can certainly utilize the computers here. There's no graphing calculators for the exams. If you want to use graphing calculators for like your homeworks and quizzes and in-class stuff, feel free to do that. But I would recommend whatever calculator you're going to use on the exam that you utilize that. There's a lot of calculators have different syntax, so you just whatever calculator you're using, you just want to make sure you're familiar with it. If you don't have calculators, I know the department does have calculators. They're just not always available. So like if you forget your calculator on exam day, there may be an extra calculator in the department for you. There might not be. So don't depend on that. Usually they're gone before I can get to them. A good calculator, I think, going through the calc sequence is the TI 36X Pro, I think. I think it's like $18 or $20 if you don't have that. It's a good one to use. It does like derivatives and integrals and stuff like that. And the print is how you would write it. So it's not just like, you know, some jumbled line of codes with parentheses and stuff. It's a pretty good one to use. But you've got to show your work on the exams, so you know, don't use it to do all of your work. Yeah, so generally, I think the yeah, so that's just a long little text about the MathLab code. Could you pass that back? Saying that you should get it in one of two ways. But this here on page 3, this dedicated support line is probably worthwhile to write down or to go back and look up. Like I said, there's always issues depending on your browser, your operating system, you know, stuff like that. So if you do run into any issues like getting this set up on your computer, I would use that as like the first line of defense. If you're still having issues, email me, then I'll have to email somebody else, and they'll have to do whatever they do. So it could take a while. Any issues you encounter, just let me know as soon as you can. I've had people like the day before the exam say, "Oh, I couldn't get into MyMathLab and I couldn't do any of my homeworks. Can you extend all of the homeworks so that I can do them?" The answer is going to be no. So make sure you're on top of this, making sure everything functions properly. Does anyone have any questions on that? Pretty straightforward. Okay. The homework notebook I don't take up for a grade, but you know, as a lot of you know, there's a discrepancy sometimes between doing math on the computer versus how you're expected to do it on an exam in class. So anything you do online for your homework, I would recommend treating that like it's an exam problem. That way you're getting in the habit of writing out your steps and being organized with stuff. It certainly would make my life a lot easier if your exams are neat. So if that's one of your things, then please work on that. I don't actually take up what you do as a grade, but I think it's almost necessary to write some of this stuff out. That's pretty much how you're graded on the exam, is what you have written out. I need to see like a chain of thought. So, you know, if you haven't done that until this point, I think it's certainly worthwhile to do. We're gonna skip this stuff. The components to the course are there's 3 components. In other words, there's these 3 things are the only things that contribute to your grade. The MyMathLab homework, the MyMathLab quizzes, both done online, and then the in-class exams. So they're homework and quizzes, the breakdown's below, but they're 20% for the homework, 10% for the quizzes, and then 70% for exams. So our in-class exams, The final's not worth any more than any other exam. The final just has the ability to replace your lowest exam score. So that's, I guess, makes it worth a little more. But if it doesn't help your course grade, then it just counts once. If it helps your course grade, it'll count twice. So for the homework and the quizzes, it's sort of tedious. It takes a lot of time to do homework. It takes a lot of time to go through the quizzes. Each section we have a homework assignment. In each unit there's a quiz for that particular chapter. But I wouldn't just blow this stuff off. It's 30% of your grade. I'll pull up a grade calculator in a minute. But if you have A's on your homework and your quizzes and D's on your exams, then you can pass the class with a C. So I'm not recommending anyone try to do that. Hopefully you want more for yourself. But I guess it's scary to see a weight of 70% on an exam, right? Like, this is almost 3/4 of my grade is how I perform one time on this one exam. So it's not, it is a huge weight on the exams, but the homework and quizzes can really help, compensate, especially if you're not a good exam taker. I know that's, definitely was my issue in school. So hopefully once we look at like a grade scenario, it can sort of, ease some tensions as far as like, how well you have to perform on an exam to pass. We'll look at these two components in a moment online. We're going to have 3 exams and a cumulative final. The final is mostly cumulative, but it will contain material from our last unit, which is chapter 12. So it's not a 100% cumulative final. The reason I do that, I've seen other people where they have an exam and then you come back and review and then you take your final exam. I just think that's a little too much. I don't know if y'all agree or not, but if I were a student, I wouldn't want to take an exam, come back, review for a final, and then take the final. It's too much. So we've got 3 exams and then a somewhat cumulative final, making up our exams. The grading process at the end of the semester, especially, by the time that it rolls around, you've probably forgotten. But I do standard rounding at the end of the semester. So like if you're at a 69.4, that's a D. A 69.5 is a C. So like everything you can do in the homework and the quiz section will really help those people that are on the cusp. It'll help you out so much. Extensions on homework and extensions on exams are usually not permitted. If it's an emergency, then of course exceptions can be made. But you do have the schedule. The exam dates will stay in place. If you've got work or something going on, you need to plan accordingly. I'm totally okay with you taking exams early. Generally, I won't let you take it late unless you had like jury duty or an accident or something like that. So just keep that in mind. Another reason for the final replacing your lowest exam score is in case something comes up and you have to miss. But again, if something comes up and you know that, just let me know and you can certainly take it earlier. I know it's not optimal, but it's better than missing class. I don't take attendance for your grade, but I do recommend you being in class. So outside of myself and office hours, email, a lot of times people just prefer to communicate through email, which is totally fine. I just ask if you're communicating through email that you do have your student email account activated and use that. If you're using this email feature through D2L, I still get the messages. I just can't respond unless I'm physically on a computer, which during the day is not frequent. But if you email me through your student email address, then it comes to my phone, so I can usually respond a lot more quickly that way. So maybe I think the instructions are still the same. Under syllabus and course information, if you haven't activated your student email account, there's instructions on how to do that. So I definitely prefer that mode of communication over D2L. So keep that in mind if you can. There's the Math Center. It's in the library. Does everyone know where the Math Center? Have y'all been to the Math Center? If you just go in the library, make a right, all the way on the end is L280. So that's where you can go to do your homework. If you get stuck, they have little flags you can raise. Somebody comes over and helps you out. The hours are there for that. And then the other service available is the ASC. They do actually have lists for like one-on-one tutoring if you want to pay for that. Really the primary thing that they focus on is study groups. So if you have like a couple of people from class, and you want a dedicated time and space to have like a study group facilitated by someone who's already been through Calc 1, you can certainly reserve a time and space through the Academic Success Center. So if that's something you're interested in, let me know and I can announce it to the class, or you can try to solicit other people to come if you know other people in class. But I'm certainly happy to help facilitate that process if you're interested. I don't know how many of you work, probably most of you, but this is like an ongoing thing. You just pick a time that works for everybody, you reserve that time, and they give you a room in the library somewhere, and it's ongoing throughout the semester. So I know people that have utilized that service have done a whole lot better in this class. So it's always a good option to think about. They're also in the library as well. I've got a handout on D2L. Some important dates are here on the next to last page, and then our schedule here. Like I said, the exam dates won't move. If we don't cover something, we may bump it to the next exam, but those are going to stay fixed just so everyone can plan accordingly and be here. And your assignments are all due on exam dates. So that's listed there. And once you go into D2L, my math lab does have the due dates and the due times next to each assignment. So do y'all have any questions? Yeah.
Is there any in-class quizzes?
No, I don't give like in-class quizzes or assignments. No pop quizzes, anything like that.
Is there a time limit to the online quizzes?
Yeah. There's a time limit to the online quizzes. We'll get into that momentarily. So I'll try to keep these two here. When I post other announcements, though, they tend to get pushed down. So if they disappear, then you just want to click on Show All Announcements, and you'll be able to access those. But this grade calculator might be more beneficial, I think, towards the end of the semester, once you have a clearer picture of your grades. Especially like going into the final. What do I need to make on the final to make an A? What do I need to make on the final to pass this class? You can fiddle with that to get a good sense. But yeah, like I was saying, if your exam scores are D's, we'll move this to an A. Let's do a 90. And this to a 90. So, like 63 on the first exam, 63 on the next exam, a 59 and a 60, with a homework and a quiz average of a 90 respective for both, you've passed the class. Again, hopefully you shoot for higher than that, just in case, but it is doable. I just see a lot of people neglect the online assignments just because it's time consuming, but if you can get those done and be at a decent score, they provide a pretty large buffer for the exams. So, anyways, that's there if you want to mess around with that. Hopefully, can sort of ease some tensions with grades and stuff. You know, if you need an A, then obviously there's a lot less wiggle room to make an A. Yeah. All right. So this is how we'll access our online components. All of our assignments will be here. So again, the due dates and the due times are here next to each assignment. The homeworks are these blue circles and the quiz is the square. So the homework is for each section, the quiz covers the entire unit. And so the quiz will probably be the last thing you do, just because we've got to cover all sections before you do that. And really the biggest difference between homework and quizzes are the quizzes are timed, the homework isn't. The quizzes, you have only 2 attempts, and the homework, you can really attempt those problems as much as you want to get whatever grade you want. So like, you know, you can start wherever, it doesn't matter. Just for like, if you're emailing me about specific questions, the question of this homework set is up here. Like, you'll notice this number change as well. Like if I'm on question 5 in my homework, this over here says 6.1, number 14. This number over here refers to the textbook itself. So if you looked at question 14 in the textbook, it would be very similar to this problem. So like if you email me a homework question, say, hey, 6.1, question number 5, I'm stuck on because of this and this reason, it makes it a lot easier, because otherwise I just have to like cycle through these and figure out which one you're actually talking about. So question number 9 of the homework, 32 in the textbook. With the homework, you have the ability to save. So like if you have to leave to go to work or whatever, you can just save your progress and pick it back up later. The print option allows you to print a specific question or the entire homework set. And you can work that offline and then just come back later to enter the answers. So the quiz doesn't have like a save option or a print option. The quizzes are treated almost like exams are. It's really weird how they treat the quizzes, but they're treated like exams where you don't get any help, you can't save your progress, you know, all that kind of stuff. The other resources you have for most homework questions are the Help Me Solve This and View an Example. I would recommend using these very sparingly, because you know, a lot of people have a tendency to read a problem like, oh well, I'm crunched for time, I don't have any clue on where to start, let me just see what the computer tells me to do, right? So you start to initiate that process, maybe refresh or refamiliarize yourself. Oh yeah, this is what I do. You know, clearly you don't have that option on the exam, and I think the students that definitely overutilize this feature, you're really going to struggle on the exam, because it's when you see a problem like this on the exam, there's no recall ability in your mind. The recall ability is coming from the computer that you don't have anymore. So use these things sparingly. It would be my recommendation. But the difference is on Help Me Solve This, they'll give you the exact problem you're working on, and you know, at some point they prompt you to fill out things. So you're kind of they're kind of walking you through the problem. You're filling this out. Once you're done, you have the answer. You fill it out here. The View an Example will give you a similar example, but it doesn't prompt you to enter anything. You can just sort of look at the steps and read through it. So just be careful with this. Sometimes they have a more convoluted way to explain stuff than kind of how we do it in class. But again, I would definitely utilize those as like a last resort. Otherwise, I think they're kind of detrimental, depending on how much you use them. Some of them have videos that accompany them. Oops, where'd that go? So yeah, again, not all questions will have this. It'll be something similar, but not exact. And then one way to access the textbook is just directly through the homework. So if we click this link, then it's going to open section 6.1 for us. They do these Wolfram files, these CDF files. So like all of your interactive figures, your interactive textbook will be those CDF files, and you need a Wolfram CDF player. To access those files. But yeah, so this is your textbook, then you can select sections from there. Everything's like full color. Some of these things like graphs and figures you can interact with. Like this one, they have sliders you can move around and kind of see what's happening. So this is definitely an advantage over like your static textbook. That and it's much cheaper. So you can access your book directly through your homework. There's like 2 or 3 other ways to access the textbook. But if you get this problem wrong, they'll ask, do you want? Well, it's got multiple parts. They'll ask, do you want a similar question? And if you say you want a similar question and you get everything right, then that's going to count for that particular problem. So it's almost like real time. You can adjust your homework to whatever you want it to be, assuming you have time.
If you put help me solve this, it'll give you the problem.
Huh?
If you put help me solve this, because you like missed the first part, it'll start it over for you.
Oh, really? Yeah, so like you could go to the next question if you're like, hey, I don't care, I missed one part of that, I missed both parts, I don't care. You just go to the next question. If you want to change that, then you just generate a similar question.
I'm gonna say close.
Oh, yeah. Circumvent the system. Yeah, a lot of people like abuse this because eventually, if you just keep clicking similar exercises, it's got a finite list of problems, and you're gonna get back to where you started, and then people just fill out the answer the computer told them.
Well, it's more helpful when there's like 6 parts and you miss like the 3rd part, and you don't want to keep doing the same one because you got it wrong. You just like start it over.
I guess, yeah. Like you do what's best for you.
It's a perfectionist tool.
We do have in-class exams, though. I'll say that. Yeah. So yeah, that's basically the homework stuff. Do y'all have any questions on this? And it seems most of you have used this, so you know this stuff is like a lot of times really particular on how you enter your answers. If it's just like 1 part or 6 parts and you mess up, like with a comma, parentheses, you rounded to 3 decimal places, but it only wanted 2 decimal places, like any of those kinds of issues, please feel free to email me and have me look at it. I don't mind just giving you the points for that on the homework or the quiz. Okay? If you wanted to like redo the whole thing, feel free to do it. Totally up to you. But I don't mind looking at any mistakes you think you've made and correcting it if it's warranted. Okay. So that's the homework. The quizzes, again, personally I would use a quiz. I would like go in, since you get 2 attempts, I would take the quiz just kind of by myself with no notes, just to kind of see where I'm at, like what do I need to work on, and then that second attempt is maybe pull out your notes or whatever. But it will tell you have 0 out of 2 attempts attempted. And it says you have 120 minutes left to complete. And then, so when you do the quiz, you also want to make sure you do have a chunk of time set aside. Because like I said, you can't like save your work, you can't print this and work it at a later time. You sort of have to commit to it when you start it. And so that's really the biggest difference between the homework and quizzes. Usually our quizzes will be 10 questions, and the quizzes won't tell you if you missed it. Like the homework tells you in real time, hey, you missed this part. Like the quizzes won't tell you until the very end. So once you've done all 10 questions and you submit the quiz, that's when it'll show you what you've missed. I think it's a pretty good, quizzes are 10% of your grade. Like I said, I think it's a good tool to use once you've done all the homework, just to kind of get a sense that first run through of the quiz, to get a sense of, what's concepts do you need to focus on a little bit more than others, and then sort of help that, tailor your study. So the best of 2 attempts is counted as your quiz average. So, there's these multimedia things here. I didn't really quite know how to organize it. So, like the way I organize it, I just put all your assignments first, and then after that, an exam review. But all of these multimedia for each unit are below the actual assignments. If anyone has a preference, if you would rather see these multimedia pieces below like each homework, I could certainly move all that around. I just didn't really know. To me, it was confusing when it was like a homework and then a multimedia, then a homework, so if anyone has any suggestions or preferences on how they want that organized, please let me know. But the multimedia is additional help, I guess. If you're like struggling with a concept, you can watch a video or these introductions. There's accompanying the particular section. For every section we have those as well. So I made all of those due at the end of the semester, so like, reviewing for final and stuff like that, you want to go through these. They'll be open until then. But also our homework is, has this HW here. The multimedia is not graded, it's got this blue circle. Don't confuse it with the homework. It should be really clear if you accidentally go into one. There's no problems here. But I wanted to make those available. I just didn't know the best way to display them really. So we have the multimedia, then our assignments again, then the multimedia. So that's how I've organized it. Do y'all have any questions? All right, this multimedia library here is another way to access the textbook with other things as well. So the textbook, we would just select this option. Some things have videos, animations, and interactive figures. So here we could access the textbook again through this route. We can also access the textbook through this chapter contents. Just go to whatever chapter we want, or section rather. Through here, like section 7.1, let's say, through the chapter contents, you have, student solution. Yeah, I need to make that visible. Sad face. If y'all, I don't know how many people actually go through the textbook. There's so many problems online, but some people do like to go through the textbook. I'll make this option after class or tomorrow. I'll make that option available so you have access to the student solution manual, which would be all the odd numbers, I believe. Okay, so again, just an alternative way to access your textbook. There's also study plans. I haven't messed around too much with study plans, but you will get additional practice problems. Through the study plan. The homework I don't reopen at the end of the semester, so once it's due, and that's it. But if you go through this grade book, you should see your homeworks, and even if they're past due, you still have the option through the grade book to review that specific assignment. So if you wanted to review, some questions and write them down or whatever, you have that as an option. Here it is. You won't be able to edit or change your score or anything like that, but you can use that as a review. Interactive ebook, standalone link. There's a link for the static ebook. I think it's the HTML version of the textbook. So that wouldn't have the figures you could interact with or manipulate. It would just be akin to your physical textbook. And there's all these other tools under Tools for Success. Excuse me. So if you have time just to go through some of this stuff, I think it's worthwhile. It's not, not only do you have access to your textbook, but there's other supplements to what we do in class. And usually what we do in class is enough with the lectures and the homeworks and the quiz, right? Usually that's sufficient, but some people do extra stuff, so all that extra stuff is there. So one more thing I want to mention here on the homework is that the homework and the quizzes are due on the day of the exam, right as class starts at 6 p.m. And I know I've gotten feedback from some students in the past that they would prefer to have a homework due every week. I guess it helps them stay disciplined so they actually do it. Unfortunately, people like to procrastinate, so I want to accommodate that as well. So if you're one of those persons that need discipline to do homework in a timely fashion, then you have to find that discipline yourself. Everything's due the day of the exam. That's how it is. That being said, I don't recommend cramming. I don't recommend doing all of this stuff the day before the exam or even 2 days before. Chances are you probably won't have enough time to do all of that. But cramming, I guess, does work in the short term. But if you've crammed, you kind of know that it does leave little gaps in your memory. Oh, hey, I totally don't remember how to do that. If you do these homework assignments as we go through them, there's a greater chance of you actually remembering that material. So that's my recommendation. As we finish a section, the next day start the homework. That way you're not, our first exam is February 13th. February 12th, you're not oh man, what did we do in 6-1? I totally don't remember how we did any of that. It's been almost a month or whatever. I would recommend keeping up with this as we go, even though they're not due until the day of the exam. Do y'all have any questions, comments? All right, so I guess priority one is just making sure you can get on MyMathLab, and that what I would try to do is just pull up the multimedia textbook just to see if those CDF files are going to work. Everybody uses different things: browsers, plugins, add-ons, whatever. So it's all sort of touch and go at first for a lot of people. So that's probably priority one, is to get on this, make sure everything's working smoothly. If it's not, try that 1-800 line in the syllabus, or send me an email. As far our class notes that we complete in class will be posted here on D2L. The completed notes. The blank notes are here for whatever section's coming up. If you want these guided notes, then it's going to be up to you to print them. I do have the first 2 sections that we're going to cover today printed out for you, but if you want anything else after 6.2, then you need to print that on your own. So I'm going to go ahead and hand these out, and I don't know, we'll get to the 8 to 15. Yeah, I can see what time it is.
I've taken every math class. Yeah, that multimedia thing was the only instruction in that. Oh, really? Those unordered videos. Wow, I don't know which one is first.
It's like pretty much the class notes.
Just random.
Do you have one of these 6.2?
Yes, integrated concepts.
Are you teaching any other courses? It's like, so we're gonna take the final early, so we'll be fasting for Ramadan again.
Okay.
And one doesn't do it together.
So-
Maybe if I could take it in one of your other classes.
Oh, yeah. You can also, like, if you want to take it early, you can always take it in class too. Really?
I mean,
With the camera,
Resident
yeah.
my brother's class.
All right. Yeah, just let me know as we get closer.
Okay.
So is this your second semester, your first semester? What year was it? 12?
Yeah, I was just, so and there's the,
Oh, yeah,
And this,
all right, does everyone have a 6.1 and 6.2? Oh, okay. So would y'all rather take a break now or in 10 minutes?
if you're gonna watch it.
Okay.
That was always funny though, because you'd have people in high school in senior year, some are doing math 2, some are doing calc 2, and they'd go to a college to do it because they from teachers. It's funny when people go to different seasons.
All right,
in high school and things like that.
So, like, I guess the overview of Calc 2, it's much of a continuation of where you left off in Calc 1, where the first, I guess, 2 units, are really dealing with integration. In Chapter 7, or Chapter 8 rather, we start looking at different integration techniques. Up to this point, you really only have one technique, is use substitution. So it's not until the next chapter where we do start looking at different ways to evaluate antiderivatives. Chapter 6 is, I don't know, I think it's kind of disjoint, but we do look at sort of a physical context of integration in 6.1 and physical applications in 6.7. But 6.2 is area between curves. 6.3 is volumes. 6.4 is volumes. 6.5 is arc length. Then we look at surface area, physics applications. And we also look at hyperbolic trig functions. So it's kind of, all over the place. But in summary, I think chapter 6 is really what else can we do with integration besides just finding the area under the curve. And then we look at techniques for integration. So we're looking at velocity and net change in 6.1. And so if does anyone remember when you compute something like this? When you compute a definite integral, what's the interpretation when you compute that? You get a number, but what is that number?
The area underneath the graph.
Yeah, it's the area underneath a curve. Specifically, what kind of area though?
That area?
It's the net area, right? It's the contribution of the area that's above and below the axis. So that's kind of the idea of net change. We're going to look at it specifically applied to position, velocity, acceleration, and then we look at a more general setting of net change for like a population or temperature or what have you. So. So what we'll notice here as we go through, what we'll notice is like if we had this a graph like this, when we compute this area and this area, in situations like that where you have equal area above and below the x-axis, you have an area, net area rather, of 0. And so what we're gonna attribute that to is displacement, the change in position from start to finish. And then we'll look at how, given a velocity function, how we would actually interpret the distance traveled. But we're going to start off with a few easier examples here, and just make a connection between what we're doing and the area. So we drive 50 miles per hour through a 4-hour trip, and we want to know what's the total distance traveled. There's our graph, it's constant. So what is the total distance traveled here?
200 miles.
Is what?
200.
200 miles.
You travel 50 miles per hour for 4 hours, right? Let me get rid of this. So we have distance is rate times time. Our rate, 50 miles per hour, and we're multiplying that by 4 hours. So you've got to remember the difference between distance traveled and displacement. They're two separate things. What would the displacement here be for this example? The change in position from start to finish.
It'd be 200, yeah.
It's still 200, right? So that's what we'll notice is that, like the graph we just erased, when there's area above and below, then you have positive and negative contributions. Think about positive as me like walking to the wall. The negative would be me walking back. So it's just an opposite direction, right? When these two examples that we have here, the function is completely above the x-axis. So in those instances where you just have this positive area, that positive area is the distance traveled and is the displacement. Naturally, that'll change according to the functions we look at, but and again, it's important to note here that the distance traveled is the same as the area. We have a height of 50 and a width of 4. So that area is 200. So in this instance, the area under the curve is the distance traveled, it is the displacement. And this sort of is a more simplistic example, but again, let me put this here on the board. When we compute this, definite integral, you know you have some sort of function value here in your inputs. When we compute this area, we're seeing exactly what we're doing with the units. What do we do with the units here when we compute an integral? The units of y and the units of x are, yeah, they're multiplied. So you're multiplying the units here. We see that directly with this definition here too. That's the y units, and we're multiplying them by the x units. Okay. So here's another one, a little bit more, I guess a little bit more choppy, but it's the same idea. If we travel 30 miles per hour for 2 hours, and 40 miles an hour for a half hour, then 20 miles for 4 hours. Is that 4? 2.5, 2, 6.5. Oops, 20, not 40, my bad. Where's that? So the distance traveled, again, the area is completely positive above the independent axis. So here, the distance traveled and the change in position, the displacement is the same. And we're just going to compute the area of each one of those rectangles. So we have already here. We have that area plus this area. Plus this area. Or let me label that distance traveled. Where's displacement? Okay. So again, we've got our units on their y-axis, miles per hour, times the units on the x-axis, which are hours. So when we compute the area, we're multiplying the units. It gives us miles, distance, or displacement. And so that's 160 miles. So something I don't know that we really addressed all that much in Calc 1. We just said, hey, here's the area under the curve. It's the net area. And we sort of left it at that. So now in this section, we're actually going to put some sort of context to it. So does that make sense? Anybody have any questions? Yeah.
Do you have any extra in this packet? I think I
Yeah.
only got 6.2.
Yeah. Does everyone have 6.1, 6.2?
My bad. That's my fault. I had it.
Okay, so what we're dealing with is speed. In general, though, we could say when we have a rate that is positive, so, change in temperature, population, whatever, is positive on the vertical axis, time is on the horizontal axis. The area that we compute under the curve, the area, is the accumulated distance here in these two specific examples, but in general, it's the accumulated change. Most of the examples, though, we look at do have area that's above and below, and so we'll look at some of those in a minute, but it's sort of a gentle introduction here. Oh, that's blank. That's blank. Okay. Which one? Fix this. Sorry about that. I don't know why this, sometimes when it opens up, it just opens up blank pages. So let's see if this will work. Okay, well, I lost, I copied that to try to paste it, but it's gone. Hopefully you wrote that down. All right, so just a few of these here. We're going to look at various scenarios, and we're going to describe what the area under the curve represents. So we've got a rowboat that sprung a leak. Water is flowing into the boat with some sort of rate, R of T, and T is in minutes. So what would a possible graph of this scenario look like? Like if we've got water coming into a boat. A circle?
Probably coming in at a constant rate until the pressure of the water inside the boat equalizes with the pressure outside.
So like constant rate and then
I don't know.
go down, go up? Answers could vary. There's not just one specific answer.
It's gonna be a constant downslope.
It could be a constant downslope, like a gradual one, like that. Is that what you're thinking? Yeah. So I mean, what do y'all think that figure on the right? Would that work? You got to remember that the y-axis is measuring the rate at which the water's coming into the boat.
When the rate increase, it'd be a faster rate as the water goes into the boat, because I would think it would be an exponential, increase, like kind of a curve.
Yeah. Yeah. So like as initially as you sprung a leak, and I guess it would depend on the boat, the whole, the body of water you're in, right? So we have like varying answers, but and initially it would this is where you're thinking, William?
Yep.
Like that.
Kind of like that, yeah.
So like initially we have like a slow trickle and then it keeps, coming in more rapidly. I guess that's a possible scenario. It's possible for the water to just trickle in at a constant rate as well. So I think all of those could be acceptable. Okay, what would the area under the curve represent for any one of these?
How much water is there at a certain point?
How much water?
Is in the boat at a certain point?
How much water is in the boat at a certain point? What do y'all think? Yeah, so like there aren't any units given, so you can just kind of make up units. This is gallons per minute maybe, and time is measured in minutes, right? If we find the area, we're going to multiply these two things together. The minutes go away. You just have gallons. So the area under the curve represents the amount of water in the boat. We'll just say that. That's fine. Okay. How about example 4? Someone's losing blood at a certain rate. T is in minutes. Here's minutes. What would that look like?
Increasing.
Increasing?
Decreasing.
Decreasing?
I would think
Like starting here?
they would clot hopefully at a certain point. Depends on how bad the injury is.
Right, so like it would eventually level off?
Yeah.
Assuming the
I
person's
hope.
gonna live, it would stop, right?
Unless your blood pressure goes down as you start bleeding out more, so then not as fast.
Yeah. So I think that's reasonable. Anybody had other scenarios? Or is that okay? So the area under the curve here, what would that represent? Yeah, the amount of blood lost. Okay. How about scenario 5? With an IV at a rate, T is in minutes again.
That would be constant.
So constant.
Then it would just stop.
It would stop. Everybody think that's all right? reasonable. Okay, the area under this curve would represent what? Medication, the amount of medication. So the amount of medicine in the patient. Okay. So those are all scenarios where the function is positive. We're going to move a little bit more to a generic kind of situation with position, velocity, acceleration, and then look at general net change. Okay, so suppose we have a straight road. We're traveling down at a certain velocity for time larger than or equal to 0, and our position relative to our starting point is modeled by the function s of t. So just a reminder here, when we have a position function, how do we go from the position function to the velocity function? The derivative, so velocity is s prime, and acceleration is derivative of velocity, which is the second derivative of position. And let's say we have, let's try to draw this. So we have this scenario, I'm just going to draw this graph here as best I can. So let's say that's our position, maybe from our house to school and then back to our house. What would the velocity look like? What would the velocity function look like? So we said the velocity is the derivative of position, meaning the rate of change of position. And our interpretation of a rate of change, an instantaneous rate of change, is what? Like a mathematical interpretation was what?
It's the slope of the function at a given point.
It's the slope of the function at every point, right? It's the slope of the tangent line. So in order to graph the velocity from position, sorry, did you have a question or a comment?
Oh, I was just going to answer your question.
Okay, yeah.
Sorry, you can answer.
No, okay, all right. So yeah, we would just think, what's the velocity doing? You know, what's the velocity doing here at this point? What's the slope at this point? What's the slope, and so forth. So those are going to measure or plot out our velocity for us. And so you see, it starts out at 0. The velocity increases. So it starts out at 0, the velocity is increasing, then it has to decrease to level off to 0, right? So through this region here, just dotted here. So through that region, our velocity is 0 because there is, there's no slope there, it's horizontal. But on each one of those curves to the left and to the right, it's the velocity, the slopes are increasing, and then they have to decrease to level back off at 0. So you look something like this. Maybe not as drastic, but something similar to that. What would it be on the far left of our graph after that dotted line? What would it look like? Would it be above the axis, doing the same thing?
Below the axis, I think it's...
Right, so these are doing the same thing except for they're opposite of what these are over here, right? These are negative slopes, these are positive slopes. So something like that. And then so what we would have here, as far as the velocity curve itself, we would have some sort of area here, and we would have that same area, but it's below the axis, so we'll indicate it as a negative area. So looking at this figure, either one, S of t or V of t, what is the displacement? The change in position? 0. Does everybody agree with that? We ended up where we started. And we see that here, specifically with the velocity function, we have the area plus our negative area. That's our net area, right? The sum of, the contribution of the positive and the negative area. What would the distance traveled be?
2
Distance traveled is 2a. What do y'all think? Yeah, it's 2a. And so the way we get that is, it doesn't matter if you're walking left or right. Like you as far as displacement goes, left and right nullify each other, but as far as distance traveled is concerned, it doesn't care. So we can think about this as a minus the minus a, or just the sums of the areas. And really what we're doing here, to sort of fit in with our formula down below, it's really a and the absolute value of negative a. So when we see that sort of more generically for any sort of function, velocity, displacement is just the net area. The distance traveled, however, is the absolute value of the velocity. So the distance traveled here poses a little bit of a problem, I guess, because of the absolute value. And the way we're going to handle that is just to look at the graph of the function. Because in order to compute the absolute value, something like this that we know is symmetric, it's really straightforward. But if we had, if we had a velocity function like this, then it's not as straightforward because they're not symmetric intervals. So the way we interpret this absolute value of the function is just like we interpret the absolute value definition. Right? The absolute value of some number is that number if it's larger than or equal to 0, and it's the negative of that number if it's less than 0. The same is true for any function. Here is v of t, but generally speaking here we have the absolute value of some function. It's just that it's the function values if and when the function is above or on the axis, and it's the negative of those values if it's below the axis. And so basically in practice, like it boils down to exactly what we did above. So like, if we were computing the distance traveled here by this velocity function, we have a graph to accompany that. Let's just call this area 1. This will be area 2. And this will be area 3. To compute the absolute value of that, all we need to know is basically when it's negative. Because when it's negative, we're going to do just what we did here. Everything that's negative needs to be made positive. And the way we're going to make it positive is we're just going to subtract it instead of adding it. And that's how we compute those integrals. So if we were to compute the integral, let's just say this is a and this is b. No, let's not do that. Let's say this is d. This has to be b and c. The integral on this velocity function here, I guess we'll write it out in two ways. The things that are above the x-axis, we're just going to add those together. but the area below, we're just gonna subtract that off. Because we know that A sub 3 is already negative. Like if we were just to compute the area from B to C, that would be negative. And so when we make that thing negative and put a negative out in front, it's like taking the absolute value of it. So anything below the x-axis is a negative area. To compute the absolute value, you just need to subtract it off instead of adding it. But it entails that we know where the function changes from positive to negative. So really, if we were to write this out, I mean, it's really that simple in practice, but you know, if we were to fully write this out, we would say the integral from A to B minus the integral from B to C, because that one's the negative one, so we're going to subtract that one off, and then plus the integral from C to D. So you know, you can imagine, depending on the function and how many times it changes from positive to negative, the distance traveled could be pretty tedious, because you've got 3 different intervals here. You could have 4 or 5 different intervals, but in practice, that's how we compute the absolute value. Does anyone have any questions on that? So you've got to know where the function's positive and negative to compute the absolute value, the distance traveled. For the displacement, it's easy. You just plug the function in, find the antiderivative, evaluate. Done. So these problems that ask you for distance traveled, they'll either have a graph provided, or it'll be a function that you should be able to graph. And then based off of that graph, you can then break it into its, you know, smaller components, if you will. All right, everybody good with that? And then just kind of visually, we'll draw this out too. If this is our function, let's just say it's doing something like that. We graph or look at the absolute value of that function. It does exactly, I guess, what we would expect it to do. Everything that's negative is positive. Everything that's positive stays positive. I guess that's a little more exaggerated, but anyways, that's the idea. It's close enough. That's what you're doing for the absolute value. Okay, so everybody okay with all of this? We're going to look at some specific examples. So we've got time measured in seconds. Velocity has units of meters per second. And we're given the velocity function on a specific interval from -3 to 2. We want to graph the velocity function over the given interval, determine when the motion's positive, in the positive direction, and when it's in the negative direction. And then we'll find the displacement and the distance traveled. So the motion here, a lot of the questions in the homework ask you for this. Motion is in the positive direction when what happens?
Increasing axis.
Okay, when it's increasing, what else?
Above the axis.
Above the axis, when what's above the axis?
The area.
The what?
The area underneath.
The area underneath what function?
Velocity.
The velocity function, right? So if you're saying increasing, what were you thinking? What function was increasing?
Like
Velocity?
Yeah, the velocity.
So the velocity, the velocity could be increasing and positive. It could also be decreasing and still in the positive direction, right? So what we want to do in order to determine where motion is in the positive direction and when it's in the negative direction, this also depends on how you set up the problem, but typically the problems are set up so it's intuitive, like up is positive, down is negative, that kind of thing. Motion is in the positive direction when velocity is larger than 0, and motion in the negative direction when velocity is negative. So again, all this entails is us to look at the velocity function, look at its graph, and then determine when it's above the axis. When the velocity is above the x-axis or the t-axis here, we're going to have motion in the positive direction. And when the velocity is below the t-axis, we have motion in the negative direction. And that's usually the convention. If it's not, then they'll tell you. It'll specify in some way in the problem. Okay, so we want to first graph the velocity function, which means we need to look at probably factoring that out. So you should be able to factor that out pretty easily. And I would say if something like this on the exam showed up, it would be fairly comparable. It wouldn't be some crazy polynomial where you have to use synthetic division or anything like that. Okay. So we're going to factor out a t, and then this is a quadratic, so it's t plus 2, t minus 1. That's how that cubic factors. This might be a little algebra refresher. So we factored that based off of its factorization. We have this graph. And remember, we want to show this graph from -3 to 2. See, that's there. And so what happens on this graph? I don't know if I have enough room to do this, but maybe. So where does our graph touch the t-axis? At 0? -1 and -2. I'll label these in a minute once we have our graph. So where does the graph start? Is it starting down here? Is it starting up here? Which one is it? Negative, right? Because it's a t cubed. It's basically a cubic graph, right? The end behavior of that. Do y'all remember that? If you forgot, there's an end behavior test that says positive cubic functions behave like that at its ends. The more, I guess, the calculus way to determine that would be what? How would we determine that?
End behavior?
Yeah, the end behavior, which is a limit at infinity, right? So if you don't know where this graph starts, then you just compute the limit as t approaches infinity. Once on this function, of course. Once you know that, then you know that this graph ends up here in the positive direction. And then we also compute the other end as t approaches infinity from the other direction. We would see that that's negative infinity. And so that this thing starts down here at negative infinity. Well, I mean, it
You also
starts.
just plug in 3 and 2.
Yeah, you can just plug in the endpoints, for sure. Definitely worth remembering limits at infinity, though. We see limits at infinity with improper integrals, and they're all through chapter 10 and 11. But yeah, so there's various ways to determine where this thing starts. We're only concerned with the interval from -3 to 2. Finite interval, you can just plug the endpoints in to see what the values are. So we have the graph starting down and ending up. What do we do at each one of these intercepts?
Change direction.
We change direction, and that's based on what? Like, how do I know that I don't bounce off of these intercepts? How do I know that each one of these intercepts, I cross through them?
Is it because you changed sign?
No, not necessarily that you change signs. Like there, you know, like this thing could do this, right? That's definitely not what the graph is doing.
Would it be a double root if the differences?
Right. Yeah, the multiplicity. How many times that factor occurs? Since each one of these zeros occur once, they're crossing through. Remember, odd multiplicities, the function crosses through. Even multiplicities, like if that were t plus 2 squared or to the fourth, that's when you would have it bouncing off. So each one of these zeros gets passed through. We're starting down here at whatever this point is, passing through this zero. We have to cross through this zero, so it has to turn around. Cross through this zero, it has to turn around, and we're ending up here at this point. So that's a decent graph for our velocity function. So now that we have that, we'll answer 1, when is motion positive direction? So what do we have here?
From -2 to 0.
Yeah, let me label these. -2 to 0. Okay, we're describing t value, so we want t in between there. Is it less than or equal to, greater than or equal to, less than, greater than, what is it?
T is greater than or equal to 2, -2.
Greater than or equal to? What do y'all
No,
think?
Just greater than.
Or just greater than?
Just greater than, because at -2 it's 0.
Right, so what happens to the velocity when t is equal to -2? The velocity is 0. There's no motion in either direction. So strictly larger than -2, strictly less than 0. Okay.
And then greater than 1, less
And-
than 2.
Greater than 1, less than 2. What do y'all think about that?
Include 2?
Include 2?
Yeah.
You're going to say include 2? How come include 2?
It's part of the domain.
It's part of the domain and,
And,
Greater than 0.
yeah, the velocity is above the axis, right?
Right.
The motion is still positive here, right? So this is our motion to the right, let's say. The thing, whatever the object, doesn't just stop right there. It's just that's the window we've observed it through. So since velocity is still positive up here, we would include that endpoint in the positive direction. So that's t is larger than 1, but less than or equal to 2. In the negative direction. Kind of a similar thing here. Negative direction on the far left, we would go from -3 all the way up to our -2. Are we going to include the -3?
Yeah.
Are we going to include -2? No. Because at -2, again, it's identical to 0. And on the interval from 0 to 1, not including 0 or 1. Now, does that make sense? Do y'all have any questions on that? So you'll either have to graph, most of the ones on the homework, the graph is provided, you just have to select the right one. All right, so how about the displacement from -3 to 2?
Take the integral
It's the integral
from -3 to 2.
from -3 to 2 on the given velocity function for displacement. So I think it's easier to work with this one since we're going to take the antiderivative as opposed to the factored version. That way we could just power rule all those terms. I mean, technically we don't have a method to undo products at this point to find the antiderivative of products, only if they're in that specific form of a U substitution. But most other products aren't U substitutions that we see. So a lot more conducive to leave the velocity function like this. And we might do a couple of these antiderivatives and definite integrals, but really you should know how to do these. So we first find the antiderivative of t cubed, and we do that by doing what?
Add a power and divide by it.
Yeah, we add 1 to the power, and then we divide by that result. So we have t to the 4th over 4, plus, what's the antiderivative of t squared? T cubed over 3. So again, add 1 to that power, divide by the same result. Minus the antiderivative of 2t would be t squared, negative 2t to the second divided by 2, just giving us a negative t squared. We're evaluating that from negative 3 to 2.
It's 5 over 12.
5 over 12? Okay. So honestly, like, I don't care what you do after this, but when you're evaluating something like this, I need to see the antiderivative on the exam. After that, if you want to plug this into your calculator, then just plug it into your calculator, because from here, it's just a tedious numerical computation. But the way we evaluate, the upper limit 2 goes into all of this first, right? So we have to evaluate that function, the antiderivative at 2. So we have 2 to the 4th over 4 plus 2 cubed over 3 minus 2 squared. That's one number, keep it together, because we have to subtract off the antiderivative evaluated at the lower limit. Cubed over 3. All right, so that's the way we're going to evaluate that. Hopefully you remember that. We'll really just kind of assume that everybody remembers that. If not, then probably should review some of those. And so even here, you know, I personally on an exam, don't worry about, you know, taking time to compute all of that. Just type all of that in your calculator, and I'm totally fine with that. I don't need to see that arithmetic. So yeah, 5 over 12. What are our units here? Meters per second was for the velocity. We're computing the displacement, so it would be just meters, yeah. 5/12 meters, whatever that is. 5/12. Should remember units. I'm honestly not picky about it, but try to remember it. I won't take off points on the exam if you forget units. But try to remember that. Okay. Questions on that? Sure. All right. Now the distance traveled on that interval. So fortunately, we have the graph. We know exactly when the function's positive and when the function's negative. So here we're computing the integral from -3 to 2 on the absolute value of our velocity function. And so we're going to base our work off of the graph. The things, the areas that are above the axis, we just leave them alone. the areas that are negative below the axis, we're just going to put a minus sign in front of all of it. That's how we're going to evaluate this. So we have the integral from, let's just write out the positive ones first, from the integral from -2 to 0 on this function. So that was positive, and then the integral from 1 to 2. Okay, so those are the ones that are above the x-axis, or t-axis rather, and then the ones that are below were the integrals, if I could fit all of this, from -3 to -2. I'll have to move this here. We want to make sure we're subtracting that one off, because this area here is, when we compute this, is going to be negative. So we subtract that negative off, we have that positive. And I'll just have to write it down here. Minus another one from 0 to 1. Do you have any questions on that? So that's, if you're asked to evaluate the absolute value of any function, or the antiderivative or definite integral, that's the process that we use. And you see this is tedious. Although we have the same antiderivative, we have to evaluate that antiderivative in what, 1, 2, 3, 4 different locations, basically. They're all individual, so this can get a little bit tedious, and there's a lot of room for error here, right, with the sign or plugging in the wrong thing. So it's just, when you evaluate these things, you want to be really, really careful. I'm just going to put the answer here, just to save some time. 133/12, or 11.08 meters. So again, if you're kind of shaky on this, you might actually just go through this and see if you're able to get that result. To a large degree, the calculator can do some work, but if you're shaky, then just try a lot of that by hand.
On tests, do you like decimal numbers or do you like exact?
Usually, if it's a decimal that I want, I'll say round to the nearest whatever place. But usually, exact answers are preferred. I mean, 11.08 is exact, but usually how to say it. I think decimals are easier because that's usually what your calculator spits out. That's how I can usually tell somebody's just plugging stuff into their calculator as opposed to like doing it by hand. But some calculators would just spit out 133/12. Just depends on the instructions. And my math lab's the same way. Like you'll notice under each problem it has this tiny print in blue parentheses that says, round to the nearest decimal place, or leave your answers with pi in them. So you just got to pay attention to those kinds of things. That's really nitpicky to me too. Like, I'm not going to take off points from your exam if you write 11.08 and I wanted 133/12. I think it's a very trivial thing. Okay. Yeah. So that's that. Yeah, one more example with maybe one or two more examples like this, and then we'll look at the more general kind of net change. But suppose we knew the velocity of an object and its initial position, and we want to find the position s of t for some value. In other words, we just want to find the function s of t. There's two methods that we can look at. One of the methods, both of the methods we know already. It's just method 2 we might not have thought about to look at finding it that particular way. But what's one way we could find the velocity, or the position rather, if we know the velocity and the initial position?
Take the integral of velocity, then plug in s of 0.
Right. So the first method is to just find the antiderivative, right? Velocity is the derivative of position. So position is the antiderivative of velocity. So method 1 we'll call the, I don't know what they refer to it as. Let's just call it the antiderivative method. Yeah, so I apologize for any confusion. I usually don't have a lot of people trying to answer questions, so it seems that we do. If you want to, like, a fair shake, let's start raising our hands. Usually I don't have people raise their hand because it's one or two people always answering. But if you want to answer, just raise your hand and I'll call on you. Okay? I don't want to make anyone feel like they're left out or what they have to say isn't as valuable as someone else. All right, and so what we're going to do is just take the antiderivative. We're going to say that s of t, position, is the antiderivative of velocity. And is that 100% correct?
You have to add.
Because there's an arbitrary constant, we can use the initial position to find what that arbitrary constant is.
Right, remember when you take the antiderivative, not a definite integral, but just an antiderivative, you always have that arbitrary constant. So really when we take the antiderivative of velocity, we don't get just s of t, we get s of t plus c. Okay, and then how do we find that arbitrary constant?
We plug in the initial position, if we know what its value is, and then it's just algebra from there.
Right, yeah. So this C right here is found by using the initial condition. Initial position in this case. And so you might have remembered that from Calc 1. That is in the most basic form a differential equation that you're solving. You're given the derivative. It says, hey, the derivative is this function. What's the original function that you started with? So that's exactly what we're doing here. That we should all remember that. Hopefully. I mean, it might have been some time since you've taken Calc 1, so if I say, oh, you should remember this, it's relative. I don't know when all of you finished Calc 1. So. All right. And then method 2, we're still using this antiderivative, but it's going to come from the fundamental theorem of calculus as opposed to just a straight antiderivative. Okay, so we'll call this the fundamental theorem of calculus method. And I'm going to end up probably cleaning this up, but when we take the antiderivative of velocity, if we look at that as v of t, that's totally fine. But in this method, it's more conducive to think of v of t as s prime of t. Does everybody agree with that?
Yes.
we'll put a bounds on this in a minute, but the fundamental theorem of calculus, basically it says that if I take the derivative of an antiderivative or the antiderivative of a derivative, what do I get? The function itself. So if I take the antiderivative of the derivative of s, what should I get? I should get s. I mean, that's loosely true, right? We still have to contend with the bounds, but that's kind of the idea of this method. But when we put bounds in, we know that it's not just s of t, right? So if we evaluate this from, I should have used a different variable here. But we'll clean this up too. But if we evaluate this from a to b, that's not just s of t. It's s of t is the antiderivative evaluated from a to b, which is s of b minus s of a. Does everybody agree with that? Are there any questions or comments on that? This is exactly where the formula for the displacement that we just calculated comes from. Notice, if I ask from start to finish, from A to B, how much did we change position? It's just the final minus the initial, right? There's your displacement. It's the net area under the velocity curve. Okay. So we're just going to change up the notation, or the bounds rather, just a little bit. So we do have a function of t coming out of this, not the displacement coming out of this. Okay. But is everybody okay with that? Because that is the basic idea of what we're doing. Okay. Let me just erase the bounds. Well, we want it to come out as a function of t, just for consistency, so I'm going to start over with a different variable. And we're going to take the integral from 0 to variable t of the velocity function with respect to x. So you might remember that that's kind of showed up in the fundamental theorem of calculus, where we took the derivative of an antiderivative, and we have this variable in the upper limit of integration. Maybe you don't, but anyways, the process is still the same. That's the integral from 0 to t on s prime. And we know that's s of t evaluated from 0 to t, which is s of t position function minus s of 0, which is the initial position. So now we're going to take these two ends, this part and this part, and we're just going to solve for s of t. And our formula that we get from this is, we can also find position by saying it's the initial position plus the integral from 0 to t on, some dummy variable, x, ws, whatever. We're going to use x here. So what is this saying? It says that your position function is, what's s of 0? Initial position. So we take our initial position and we add to it what? What is the integral from 0 to t of v of x dx? What is that giving us? Displacement, right? So your initial position plus how much you've changed gives you this particular function. Now, I want to highlight a couple of things here. This t, that is the input for our function, is the same as this t. the place where we choose to start, typically at 0, is this 0 here. So it's the same value, or the same variables there. I could say, let me compute the position at 20, and I would say, all right, well, that's the initial position plus the integral from 0 to 20 on v of t dt. We'll just use v of t here now because this upper limit isn't a conflicting variable. Most of the time you're starting at time equals to 0, but it definitely doesn't have to be 0 there. The main thing is that wherever your initial is measured, time equals to 3.5, that's this lower limit of integration as well. All right, so we'll just say, for example. So really, if you have a velocity function and it says find position, there's 2 ways to find it. Does anyone have any questions on either of those? Yes.
The scope.
Up?
Yeah.
Tell me when to stop.
Right there.
Okay.
So how did your dx turn into s prime t dt instead of s prime?
Oh yeah. Thanks. I always mess up with those things. That should still be x. This should still be x. Yeah. Thank you. Yeah. These bounds here are for x. This is an x value, and this is an x value. Yeah. Appreciate it. Okay. So you should be familiar with both ways. The homework does say use both ways and verify that it's the same. Granted, there's no way for anyone to check whether you're actually using both, but if a problem shows up on the exam that says use both, you've practiced, you know, you can do it.
You just scroll back down to the.
Yeah, sure.
Thanks.
Yeah. And so these 2 things that we've listed here, in context of position and velocity, it could also be applied to velocity and acceleration, and more generally speaking, it could be applied to any rate of change. Like it doesn't have to just be velocity, position, acceleration. Does everybody have what they need here? All right, so we've got a velocity function and an initial position. We want to graph the function, determine when it's moving in the positive and negative direction. Since we're kind of running a little behind, I'm gonna skip part A. We've already done an example like that. We want to determine the position function using the antiderivative method and the fundamental theorem of calculus method. So we'll look at how to do that. So we want to find S of t. And the way we're going to do that with the antiderivative method is we're just going to take the antiderivative of velocity use the initial condition to solve for c, and then this whole thing on the left will be our position function. So we're going to take the antiderivative of our 32 minus 2t squared. And that's going to give us what?
32t minus 2/3 t cubed.
Minus 2/3
T cubed.
t cubed. Do y'all agree? Am I missing anything?
Oh, plus c.
Yeah, plus c. Okay, so really this thing here on the left, all of that is the position function. So I'm just going to label that as such. And we know the initial condition there was S of 0. When t is 0, the position is -3. So we're going to use the initial condition. So I'm right to left. But the initial condition says that S evaluated at 0 is -3. So we know all of this stuff evaluated at 0 is -3. So what is C? -3, right? Everything zeroes out. Just be careful when you have exponentials, right? Exponentials evaluated at 0 doesn't zero everything out. So just be careful. Here does zero out, so we've got C is -3, which means we just need to put that in for this C right here to to determine what our position function is, right? Okay, so let me write this here. So that's our position function using the antiderivative method. Any questions on that? Okay. The fundamental theorem of calculus method, just write this here. So it says that S of t is S of 0 plus the integral from 0 to t on our velocity function. We actually already have that information, right? We know that S of 0 is -3. We know the antiderivative, we just need to evaluate it from 0 to t. So we have 32t minus 2/3 t cubed. Do we need a plus c here? No, because we're evaluating a definite integral. The c's would just cancel out anyways. So keep in mind, we're evaluating this piece from 0 to t. Sorry, I did it again. Let's just put a dummy variable there. Oops. X dx and x. Sorry, that's setting a bad example. My fault. If you did that on the exam, I wouldn't take points off. It's kind of a minor thing. It's super technical, but it's minor in the grand scheme. Okay, so then we're going to plug in our t. Again, just be careful. If this is an exponential, plugging in 0 is not just going to cancel everything out. Okay, so we're going to plug in our t. And then our 0. So at the upper limit, minus the thing at the lower limit does 0 out, so we'll just write that out explicitly. And you see we have the exact same function, right? It's -3, 32t, -2/3 t cubed. Rest of t. Does anyone have any questions? forgot to take roll, so I'm gonna do that. So we'll stop here. We've got another example, but on this page 7, what you have here is sort of the context we've been working with, velocity, position, acceleration, and the column on the left is the more generic ones. So we can look at it, instead of displacement, we can look at just in general a net change. And instead of like a future position S of t, here we're using the fundamental theorem of calculus method. In general, we would just say that's a future value of some quantity. So we'll look at a couple of examples that will kind of go in line with this column over here on the right next class.